Hello, everyone. Good morning, good afternoon, whatever you are. My name is Thiago. I'm a CSM here at Taguayo. Today, we're going to present a webinar together with our partner, Franco from Engiko. Very happy to have him here. He's been with us with so many years now, and we're going to be focusing today on how we can use sensors to revamp our industrial integrations. Here, he's going to share some technical insights. We're going to start with a little bit of context, what the sensor is, what it's capable of doing, what is the objective, the different scenarios that we can apply that technology um, to our projects and businesses. So let me jump in here. So I would like to thank everybody to be joining today. I Some of you already know me. Work with customers all over the world, and I hope that today's webinar can bring us plenty of insights, and we can help you through achieving your goals in this industrial market, which is very competitive right now, and that Franco can provide a lot of insights in terms of the technologies that we can use, how to apply them, what will be the best case scenarios. Um, and I'm going to be sharing a little bit of context on how we can get there. What is our basic understanding? What do we need to know beforehand? We're going to be talking about the sensor integrations. Franco is going to talk a little bit more about detail. How is the technical part on his side? I'm going to be sharing also the IoT ecosystem, where that fits into it. We also have a couple different examples of how this integration would work. Then some tools that can revamp a little bit more um, our applications, such as application tool, right? So generating reports, analytics, user system, sensor management, plan management, organization setup, and all that. And then we're gonna be presenting a live demo on the end. Franco's gonna present a live demo on his side with his sensor, and I'm gonna be presenting a little bit on my side, showing more the capabilities of Taguayo itself and the dashboard and what we can accomplish on that. I would like to invite everyone. Please feel free to present yourselves there on the chat. Marcel is going to enable the Q&A in a little bit for us. So feel free to ask questions. We're going to take your questions to on the end of this webinar, and we can go from there. Let's do it. So let's talk about sensors, right? So how sensors work? So basically, sensors are devices that detect and measure physical properties. So we think about pressure, temperature, light, motion, and all these kind of things. So they can convert physical properties into electrical signals. They can be processed and transmitted by other devices. For example, we can think about a thermometer. This is a sensor that converts temperature into voltage. So now we can see how different information can be created by basic sensors, right? So we can combine multiple sensors and applying different algorithms to the sensor data. Then we can extract this information from the physical world. So let's think now about a camera. Camera is a sensor that captures light, but by applying images processing techniques, we can extract information such as faces, objects, colors, and etc. Right? So when we think about end devices, end devices they process and transmit the information from sensors. End devices are devices that receive the sensor data and perform some functions based on it. So let's think about a smartphone. A smartphone is a device that can display sensor data on its screen and send it to other devices, right? It can be like, for example, via wireless networks. And devices can also perform uh, some computations on the sensor data to reduce like bandwidth or power consumption, etc. So how we can understand this information, right? And combine and create new business models and revenue streams. So by aggregating and analyzing the sensor data from multiple sensors and devices, we can generate insights and value for various applications and industry. So, for instance, when we combine the sensor data from smart meters, smart appliances, and weather stations, we can optimize the energy consumption and distribution for, business, buildings, smart cities, utilities, households, and so on. So, what is sensor integration? And now focusing a little bit more on the industrial side, right? So let's go through CAN, Bus, RS 485, and I2C models and other protocols, for example. These are communication standards that allow different devices to exchange data over a network. They have different features and advantages depending on the application. So let's use the CAN bus as a first example, right? So they're widely used, for example, in automotive industries because it's more robust, reliable, and fast, right? While the RS485 is suitable for long distance communications, for example, not and it has like a noise immunity. The I2C, we can fit in a category which is a simple and low cost and can connect with many devices on a single bus. Now, the cool thing is that this allows an integration with series of different applications. We can think about car wash lanes, lighting, heating, conditioning systems, sensor, and other devices using these protocols. Basically, you need a device that can act as a bridge between the protocol and the device. For example, you can use CAN bus controller to connect to a car wash lane to a CAN bus network. You can use a RS485 converter to connect a temperature sensor to a RS485 network and have the ability to use, for example, a 2C expander to connect with multiple switches in the I2C network. And then finally, you need a device that can send and receive data from the protocol network or to any device or to any other system. For example, you could use a CAN bus shield to connect like Arduino board to a CAN bus network. You can also use like the RS485 module to connect to a Raspberry Pi or a RS485 network, and also use I2C adapter to connect to a PC or like the I2C network. So this is all the theory, right? Like I said, later on we're gonna see some examples of this integration. Franco is gonna share a little bit more on the tech side, how the Engiko words will treat that information and how it can be helpful in connecting the dots there. So with no further ado, I'd like to welcome Franco. Franco, thank you very much for being with us here today. We're very happy to have you here as a partner, as having this amazing hardware that you have. So I'm passing over the stage to you, and I hope everyone enjoy.
Hi, thank you for this opportunity. I'm Franco Zampiccinini, and I'm technical sales engineer in Engiko. In Engiko, we manufacture end devices. So, as I told you before, there are bridges between the real world and the data. Our devices are mainly LoRaWAN devices, so wireless devices, and one of our main product is the Modbus device. The Modbus is an industrial protocol that was born in 1979 and is many years on the field. So there are a lot of devices, industrial devices with the Modbus protocol. Basically, there are two different kind of Modbus. The Modbus RTU RS485 or RS232 that is based on the twister or twister lines, or the Modbus TCP that is Ethernet-based Modbus. The Modbus is a very robust protocol, is very well known from the industrial side, and you can connect devices from several hundred meters far from the master. The Modbus protocol has one master and several slaves, up to 31 slaves. The communication is based on differential signals using twisted pair cable. Is a half duplex and is very robust against noise. There are some tips to implement to have the best Modbus communication from the devices. Termination resistor, since it's a differential signal, the lines must be terminated to avoid the reflection on the line. Polarization resistor, since there are three states on the lines, there is the 0, the 1, and the high impedance state. When the line are in high impedance, you need to keep them in a well-known status, so you have to add the polarization resistor. So from my side, I can tell you that the Modbus RS485 is a very robust protocol and adapt to industrial environment. And with our device, you can make any industrial Modbus RT compliant slaves a wireless device, because with our Modbus to LoRaWAN interface, you can add the LoRaWAN connectivity to any industrial Modbus slave. In our portfolio, we don't have only Modbus device. We have several sensor. As sensor, I mean devices that can measure and send through the LoRaWAN physical parameter like distance or the energy consumption or the particulate matter in the air, or rainfall, temperature, humidity. Or we have bridges that, serial to LoRaWAN, Modbus to LoRaWAN, USB to LoRaWAN. So you can choose the best sensor, the best interface for your application, and make it LoRaWAN connected using one of our device. But LoRaWAN doesn't mean only read. You can also do things. This is why we also have actuator devices with digital output to switch a load and to control heater, pumps, fans, based on the data read by other devices. As I told you before, with the Modbus, you can use any kind of Modbus RTU RS485 device on the market, and you can use it to measure energy consumption from the single phase energy systems to big three-phase plants or transformer. You can do things, so you can drive analog output, you can drive digital output, or you can change parameter on inverter or other kind of devices. You can read the heat using a heater meter, or you can also chaining up to 31 different devices on the same line. So it's a very easy way to add the LoRaWAN, the wireless connectivity, to the devices. And thanks to the Tago platform, you can handle this data in the best way to make them very easy to read and also very easy to send data to the fields. So, as example, using our MCF LW06485 Modbus to LoRaWAN device, we can connect an LCD display, and thermocouple sensor, and a fan controller. So with the thermocouple, you can read the external temperature, you can display it with the LCD display, and you can turn on or turn off the fan based on the temperature. The logic of the system is on the application, is on Tago, but the connection to the real world is made through the Modbus line with our interface. This is a picture of the setup that I'm talking about. So you can see the LoRaWAN interface from Engiko, a thermocouple to Modbus slave made from another supplier, a relay output Modbus slave that made for another supplier, the display to show the temperature and the fan that we have to control through the application. So let me show the application. This is the what I can see on Tago. So I can see the temperature of the two probes, the temperature of the cold junction, the status of the output. So based on the temperature, I can decide to drive the fan or to turn on, turn off the heater. So with the possibility that Tago offers, you can combine different actions based on the data received. So with every kind of, virtually any kind of industrial application can be handled by the Modbus RTU interface, because on the market you can find from the simple sensor to read one input, one digital input, to read the flow meter, or to drive something from a light to a heater to a motor and changing the fan of the motor. So, from my side, for the technical presentation of the Modbus RTU, I think it is all. We can talk more about after the presentation in the Q&A session.
Sounds good. Thank you, Franco. Thanks for elaborating a little bit more, giving us some more context on how this would work, how we can connect them. So now let's look at the IoT ecosystem, where we would see that, right? So we have on our left side our physical properties, the end device that's capturing that information for us. So we can have thermometer, we can have an automobile a sector sharing with us, for example, RPM, speed, fuel. We have like level sensors, we have GPS, we have different properties that can be converted uh, using these devices. They will send this information through LoRa, for example, in this case, and then LoRa will do a webhook to the application, to the platform, so you can create your analytics, your business case, right? You're then being able to add things, which I'll share in a little bit on my live demo, um, the reports, and create custom alerts, plan managements, so limiting how many SMS notifications, emails, right? All that like high level detail that we want. Create our sensor management and organization management. So now we're thinking about, I could have different groups of devices, groups of gateways inside a building. I could have multiple buildings, and could create different permissions. So I have this user accessing a particular sector of the company. I could have my end user just visualizing what has come down at his end. I could connect a distributor in the middle. And have him involved in this process as well. So a lot of different capabilities, and we can dive into a little use case that I've put together so we can analyze in a very simple manner what kind of information can we bring in to bring in value to the project, right? So in this case here, this is an example of an integration overview. So we have, for example, our edge computing, which is receiving this information from the sensors. He's providing the control to the user so he can, for example, turn on, turn off, manage those particular devices, sending a downlink, open valve, close valve, turn off sensor, and so on. Then send that information to the platform, display, for example, locations, the status of the sensor, do like KPI calculations, integrate with third party like SAP, CRM, um, Google Analytics, Drive, or other parties that could use that information and revamp even more the application in this case, and then providing access to the enterprise, right? So you could forward that information, provide make that information available to your users depending on their level of access. They could see different things, they could manage different things, and so on. So here we can see a couple examples of data visualization. So at first on our back, we have our like an energy metering dashboard where we can monitor voltage and activity. We can have status of on and off of our devices. What are they reporting? On the next one, we have a simple sensor of geolocation, temperature, and humidity, which allows us to send commands back to that sensor. And on the right side, we have RTLS, which fits perfectly in this industrial case because here we could not just manage the location. Its primary purpose is to manage location, but we could add much more beyond that. We could track the location. We could track the status of that particular machine. Has that machine been moved from one place or the other? What kind of data is that machine reporting? Pressure, um, voltage, battery, RSSI, and then we can make some cool calculations on top of that, which I'm going to show before. You could calculate the productivity of that particular machine and sensor that you're tracking. For example, you could do like a countdown based on the vibration to let you know when are you going to need to give some maintenance on that machine, right? When are you going to need to go to that machine and say, okay, this machine has been operating for this amount of time, the vibration is this, and now we need to take action. When will I take action? So we can anticipate some problems like a downsize in productivity, and through the vibration calculate what is the productivity per se. For example, detect if my machine is performing at 81% of its capacity, at 60% of its capacity, and so on. Talking a little about use cases, what are the most popular ones that we see today that fits this criteria that we are discussing, right? Which are more industrial, right? So we have, for example, smart buildings in cities. We have water meter and energy metering, industrial IoT and predictive maintenance, which is the example that I'm going to show today, and also facility, right? Of course, with Modbus, you can. It's really, if you think about it, it's limitless because you can connect so many sensors and you can use that information on your dashboard from a series of different cases. Focusing today, of course, on the industrial side of things, we figured that, for example, smart buildings, it's a case that it's ever growing. We've seen so many buildings that they don't have, for example, a leak sensor or a CO2 elevation detector, um, turn on and turn off lights, open and close door, some things that could make a difference inside, for example, a condominium, water metering, energy metering. All these things could be tracked. A lot of problems could be anticipated. Forecast could be made on top of that. Billing could be generated on top of that. Different access could be provided. Okay, so I have one condominium with four buildings, right? So I have a super per building. So he's gonna access and he's gonna manage that entire building. Inside the buildings, we have the apartments. So I could provide my user access to a particular apartment, and he would be allowed to view his information, view how much his consumption is, right? So there's no need to get one bill per building and split equally. Now each one will have its organized form. So looking at this scenario, IoT could not just prevent and anticipate a lot of problems, but could give us a north on, what each user is doing, how its sensors and equipment and utilities are behaving, and take a next step. The same thing is for water meter and energy metering. Water metering being on the most important. If we think about, splitting the bill equally, it's not fair. Once some people use more than others, you would see per apartment or per building what is the consumption. You could put generate billing on top of that. You could add leak sensors there to anticipate and prevent problems. Like, for example, you have an apartment you only visit once a year. It's like a summer place, and it has a leak, and you only discover, months after You arrive there and see that everything has been damaged. Where a simple leak sensor could just receive an alert, let you know right away what's going on, and you could take action. You could even trigger, for example, for the super to have to get like a message and say, "Hey, apartment 1B, they're having an issue there. There is a leak," and so on. So this can be very helpful in series of ways. One of the things that I'm also going to be focusing today a little bit of my presentation is the ability to apply analytics and generate reports, right? So in this case, this is Engiko device as well. So here we're looking at, for example, real-time data visualization and analytics of a weather report, a weather station monitor. By the way, this example of dashboard is available on our website under product and dashboard, then dashboard templates. You can use this layout if you're putting together, for example, a case for water metering. You could simulate. I'm sorry, weather station, and you could simulate how would that look like. You can customize it, add a device to it, connect it, and get the logs, work on the forecast, and build this dashboards and apply it to your own use case. This one we have this one, and we have series of other dashboards which apply directly to the industrial sector. Another, like I mentioned before, business rule and case. A lot of features includes the alert setup that I'm going to show you guys a little bit how that works. I'm going to show how we can generate PDF reports based on all this information that I've been discussing with you guys, and business role and case. So you can apply very. It could be very robust. It could be simple. The idea is that you are empowered by Toggle to apply your business rule. You have the ability to create custom scripts that can benefit your project in order to build cases, for example, custom reports, auditable reports, um, create rules, for example. I want to know. Let's look at the scenario where we are at the cold chain, right? At a fleet management scenario. So I'm tracking my fleet, and I see that one of the trucks had a hard stop, and my accelerometer detected that and sent me the message. So now I know what happened. So that's one scenario. Another scenario will be, for example, um, transferring something which could be uh, um, compromised if um, applied to a climate, for example, a difference on temperature. Let's say I'm shipping something from Vegas to Canada, right? Or vice versa. So I know Canada is very cold. So once I ship something from there, I want to get the temperature of what I'm transporting it. And if there was a variance on temperature, I need, not myself, but my customer needs to be able to reassure that no, my product is safe. The temperature was this, the maximum variation was this. So we deliver it at Vegas. Everything was okay. It was within the range, everything refrigerated, nothing was compromised. But if the situation was otherwise, we would have the ability to create that business logic and pass that over to our users, customers, and eventually end users, right? So now let me show a little bit to you guys what I'm talking about, so we can have a visual perspective of how would that work in practice, right? So here I have, for example, my IoT application, and here you can see that I already have some blocks that are built in, and some of them, actually most of them, I got from the Kickstarter app. If you don't know what the Kickstarter app is, you can also go to product and then Kickstarter. If you're looking to have some modules ready to go, for example, I need user management, I need sensor management, I want to separate my sensor by group, I want to create alerts, reports. The Kickstarter has already have all that. So if you want to take advantage, you can see through there, um, and but with a bunch of other resources, you can customize it, you can white label it, and make it your own. add your sensors main functionalities, and take it from there. So here, for example, I have my admin dashboard with a couple different organizations, which these are my customers, right? I have my sensor management. So I have a bunch of sensors here. I could add new sensors simply by giving them a name, selecting what network would they be into, add my sensor models, and assign it to a particular group. I could also enable features like QR code. Like I have 15 sensors here. I don't want to type the UI one by one, so you could simply QR code it, or add a. We even have a dashboard under the page that I shared below, which is the dashboard templates that allows you to import devices on bulk. So Tiago, I have 200 devices here. How can I upload them all at once? I don't want to do one by one. So you could create a functionality that could bring all that at once. I would then group my sensors into a particular set like I have here. I have my sensors under Taguayo headquarters, I have under the California office, and I have a case here, for example, for exotic car rental in New York. So these are all different sensors that I grouped for each case that I have, which is like subcategory of my sensors. I could create alerts either by selecting individual sensors, or I can get the entire group like I shared below. So if I have, for example, Tagayo headquarters and I create a notification, all my sensors inside that loop would be affected and will be observed for any threshold variances. The same thing here is for my sensors. So I have created, for example, I have three freezers. I have alert for humidity and I have an alert for temperature. And we can see the rule here. So for example, for humidity, if it's less than 30, I'll send a push notification. If the temperature is greater than 21.11, it'll send me a push notification because this is the threshold that I set. And the cool thing about it is that you can concatenate that message. So if you see here on the bottom where I have my cursor, you can see, for example, sensor type alert. So we know this is a temperature humidity alert. So it will let me know that the device name, so it will let me know the name of that particular device, has reported a variable, and then it'll catch, is it temperature, is it humidity, is it battery? So and it will replace that for me of value. So why is this a cool feature? Because it will not just know you have an alert. It will let you know where that alert's coming from, what is the device that is reporting that alert. You could add a timestamp to it, which is not I didn't add it here, but it'll be a cool feature to have, and the value that is reporting. One also cool thing that you can add is it reported a value of 19, but the threshold is 21.11. So we'll let the user know how much off is that particular machine or equipment is reporting, what type of what's the quality that the sensor is providing. For the reports is the same logic we could do by either sensor or by group of sensors. We could set the report as active to be sent automatically once every now and then. So in this case, I have to be sent every 5:30 UTC every Monday, and then I have my recipient here. For my other sensors, I don't want to be getting constant reports, but they are the type of sensor that I need on demand. So I leave them as inactive. And when I feel like I need to know the information for that particular sensor, I just use the control send now, and I will be getting the reports. User management. This is a really cool feature to have as well. When I invite a user to my application, I can either say, is this user an administrator? Is this a guest user? Why? Because if he's organization admin, he will have the power to create new sensors, delete logs, um, having some controls that would affect the application, let's say majorly, but not entirely, because remember, here we are at our run. So our run is our application model, so the user won't be able to do a lot of messy things over here. But if he is a guest, if it's like an end user, like this guy just needs to view the data. So he will be a guest. He will be invited to the application. He will have access to a particular set of dashboards. He will have no controls. Again, these rules can be determined by the business case and rule that I shared before, right? Each company has its own way of dealing with user management as you see the need of their business case. And finally, we have our industrial dashboard, right? So here I'm monitoring four machines in a particular sector of the industry, of this particular company. I'm calling sector B. So here we have the status of each machine. So we have M1, M2, and M4 operating its current voltage right here. We see that M3 is not operating, so there's no voltage together with it. Signal's okay. We have a good signal there. And one cool thing about this dashboard is that I'm using vibration so I could calculate the productivity, like I mentioned before, on my machines. So if we see the logs here below, we can see machine 1, machine 2, 3, and 4. You can see the current temperature, which is also represented here on the heat map. So you can see the four machines layout there. And the more red it gets on the center, the higher the temperature. So we're keeping it cool right now. The current voltage and what is the vibration for that particular machine. So once we detect the vibration, we can make an algorithm that will let us know, for example, what's the productivity on that particular machine, right? Is it working at 100% of its capacity? It's producing as much as we wished for? Or for how many days has the machine been running, right? And when it will be the next maintenance? It gives us insights on the productivity. So here I have this the sector B overall productivity. So what do we see here is basically sensor M1, M2, M3, and M4. I can see that M1 is good. Its productivity is 97%. So out of these four sensors, it's responsible for 30% of the productivity. M2 is 87%. So it's working at a bit lower capacity. Its vibration, it's reporting something that is a little lower than M1. And then we have M3, which is even a little bit lower, represents only 25% of the productivity of this particular sector. And we had some issues with M3. So what M3 shows us here is that it's working on 52% capacity, brings us an alert there. So why is that happening? Why is working so low? It's representing only 16% of the overall productivity. We have a couple extra widgets here, a couple diesel tanks there, which show us, the fuel of this particular sector. This is just to give you guys a taste of what can we do, like to bring values, just using these external physical properties and transforming that into really valuable insight. So this is from my side that I would like to that I wanted to show you guys, just sharing a little bit more about the capabilities, and I hope you guys liked it. So again, thanks for everyone. Thank you, Franco. Appreciate your company there on this webinar, and I'll see everyone on the next one. Thanks, everybody.